Welcome to Getting Started with GVERSE Geomodeling. Today's agenda starts with launching the geomodeling application and configuring the interpretation. The interpretation is a saved set of configuration parameters that's saved into an interpretation file, so the next day you can open up the interpretation file and begin where you left off the night before. We're also going to be able to open your saved GeoAtlas maps directly in the map view within geomodeling, so you can preserve your investment in all your GeoAtlas maps directly in GVERSE Geomodeling. The next thing we're going to do is to configure the geomodeling topology engine. The topology engine keeps track of all your surfaces and maintains them with triangulation and minimum curvature smoothing in real time. It also maintains relationship between surfaces like conformance relationships, cross-cutting relationships like fault offset and unconformity trimming, and automatically generates isocore or isopack maps on the fly. Next, we're going to be opening up existing XSection cross-sections directly within geomodeling. You probably have a large inventory of XSection cross-sections that you've been working with. You can save that investment by simply migrating them into the geomodeling interpretation and using them directly in there. Next, once we have your XSection cross-section within geomodeling, we can make any necessary modifications to the display and then save that as a geomodeling cross-section template that we can use to apply to other cross-sections as we build them within geomodeling. Next, we're going to define a new geomodeling cross-section. These are defined very much the same way with the same type of workflow you would do if you were working in GeoAtlas and XSection. You would simply select the wells on the map, launch the cross-section tool, and then apply the template to do the formatting for you. Next, I'm going to show you how to pick tops within the cross-section inside of geomodeling. Then we're going to apply the geomodeling tools. We're going to be modeling an unconformity play up in the Williston Basin in the Saskatchewan province of Canada. This has an unconformity surface with angular unconformities trimming against the unconformity surface that we're going to model dynamically using the topology engine. And finally, we're going to view the entire 3D geomodel within the 3D view within the geomodeling application. So now on for the demonstration. Here I've got the AOI and the project activated that I'm going to be working with. But first I want to show you the GeoAtlas map that I will be migrating into the geomodeling application, and also the XSection cross-section that I've been using that I'm also going to be migrating into the geomodeling application. So we'll just launch it here from Project Explorer, about 5 icons down. When it first launches, it gives you this new interpretation getting started dialog box. This is to help new users that have never been into geomodeling do the 3 or 4 things you have to do initially to get this thing configured and going. It's not hard at all, but they are required. The first decision we have to make is within what we call the interpretation options, and I will show you how to open that once we get into geomodeling itself. But we'll just open it from the new interpretation getting started dialog box. And here's where you make the decision whether or not you want to load all the wells within your active AOI into the model, or do you want to do the load on demand. Load on demand is good if you have many tens of thousands or hundreds of thousands of wells in your AOI, and you don't want to be having the overhead of trying to model all those wells all at once. So you can use the load on demand and then simply load in the wells that you want to model as you do your interpretation, and then you can load more wells either with things like well filters, or as you build cross sections, those wells are automatically loaded into the model, or you can manually add the wells by simply selecting them on the map, right clicking, and then loading those wells into the interpretation. Even though this project is relatively small, I am going to go ahead and use the load wells on demand to show you how that feature works. So there's no changes here, so there's nothing to do, so I'm just going to cancel. The second decision we have to make is done inside the GeoSurface Model Properties dialog box. This presents to you your currently active stratigraphic column, and all you do is select the surfaces, or the tops, however you want to look at that are in your currently active stratigraphic column, and those tops will automatically be loaded into the model for the wells that are selected for the model. Another thing I want to draw your attention to is the sources. You can have well points coming from the well-based database, or you can actually harvest the data points off existing isomap layers. Additionally, you can load isomap layers directly as a surface source, or use GVERSE Geophysx to load depth-converted seismic surfaces directly in here. And so for the detrital coming from the seismic volume, that's exactly what I'm going to do. I'm going to go into GVERSE Geophysx, pick my GVERSE Geophysx interpretation, pick the surface that I want to use as the source of the detrital from a seismic volume. So here's my detrital S, it's a horizon in GVERSE Geophysx, and then choose the volume, the 3D seismic volume it's on. Surface constraints, we're going to talk about this in a little while as we get into actually modeling, but basically what you're going to construct are a series of isochore maps between the surfaces within the conformance hierarchy that maintains the conformance as you get into deeper and deeper horizons that may not be as well modeled. If I had any faults, you could load them in here. I can also network my series of unconformities, so I can have younger unconformities cross-cutting older unconformities, or younger faults cross-cutting older faults. And then for the zones, we're going to go ahead and configure one. And I'm going to do from the, and we'll talk about the stratigraphy in a little bit, from the Madison to the detrital surface, and we'll go ahead and give this a name. Call this Madison to detrital. And go ahead and click OK. So now we have the basic configuration done, and just click close and close out of the new interpretation wizard. And let's always work full screen. And I'm going to close the 3D view for now. We'll get into that a little bit later. Click on the full screen so we can see all the wells that are currently displayed. By default, it will always look for a well spots layer to put in this list of GeoAtlas layers. So if you have a layer called well spots, it'll automatically configure that, so you at least have something to look to. Right now, if I toggle off the well spots layer, I do not have any interpretation wells loaded, because remember, we did load on demand. So the well spots layer simply shows us the position of the wells around the AOI. The next thing we're going to do is open an existing GeoAtlas map, and that's done up here from the ribbon. So we go up here to the Home ribbon, to the Open GeoAtlas Map button, press it, navigate to the GeoAtlas map I want to open, which is this base map, select it, and then it will automatically load all the layers in the same order as you have for that map in GeoAtlas, so you can preserve your inventory of GeoAtlas maps very quickly. Now notice on here under the GeoAtlas maps tree over here, I've got two well-based layers, an XSection cross-section layer showing two lines of section of XSection cross-sections. I've got a 3D seismic outline, this gray outline here, and I've got the sections and township grid also showing on here. Now why don't we go ahead and just save this for right now. I'm going to save my interpretation because I've configured it so far, and I can call it my interpretation, or you can put your initials on there and just save it. What that saves is the configuration we've done so far, so the next time you open up GeoAtlas or Geomodeling, you can then just choose your interpretation file and it would open up to you to this presentation. So before we actually start making cross sections, why don't we bring over some of the X-section cross sections? Now there's a couple of ways of doing that, and again that's up here on our ribbon. So add X-section cross sections allows you to actually browse over to the location of your X-section cross sections. For example, here's one that's saved, so let's bring that one over. Makes the conversion on the fly, and also it presents to you the opportunity to add other surfaces or other correlations that are actually in the X-section cross-section and bring those surfaces directly into the geomodeling. So yes, I want to go ahead and bring those higher stratigraphic surfaces into the geomodel, so we'll go ahead and add those in there and proceed. And I do want to see the cross-section. So there is our first migrated X-section cross-section, and it is automatically added to the cross-section tree over here. Here's the X-section number 1, SSDX. The SSDX is the common format between X-section cross-sections and geomodeling cross-sections. Now another way to bring them across is with the X-section layer. So I want to make sure that the X-section cross-section layer is selectable. So down here in the layers list, I make sure the X-section cross-sections is selectable. Click on the line of section, right click, and just add X-section cross-sections to the interpretation. And again, yes, I do want to see it. And there it is, with pretty much the same formatting that was in the cross-section over here at X-section, with some notable exceptions. One of those is, and you'll notice that the surfaces here are bent. That is because this is an equally spaced cross-section, but these are actually these live geomodel surfaces. So we call this true space mode. Now we want to change the layout here to look more like the X-section, so we're going to do some formatting here. Let's go ahead and make this full screen to make it easier to see. And the formatting is done almost the same as you would in X-section. I'd say there's an 80% overlap in the way you would format this cross-section as the way you would format it in X-section. So we'll start with the wells logs. So again, you'll see your well list. If I go to the layout, you'll see it's equally spaced. Here's your scaling, just like you would in X-section. It's an edge to edge, so the correlation lines go to the edge of the template. Now down here, this is something different. It says true space mode. That's showing the 3D surfaces. Well, I'm going to change it to straight line mode so it looks more like it did in X-section, and just hit apply so I can see what it looks like. I can go to faults. Well, I don't have any faults on there. Display options. Again, here you can say how do you want things to look. I'm not going to go into this, but you can go ahead and look at this on your own. Look at the help files. Interpolation is almost identical to the interpolation in X-section cross-section. Digital headers is basically the same thing you'd see in X-section cross-section. What do you want to see above the well symbol or below the footer? And then marginalia, again, is showing you your vertical scale and your horizontal scale. You have both of those in here. You don't have those in X-section. Plus various other things like margins and line labels of the like. So I'm just going to go ahead and click OK. Now it's configured the way I want it to be configured. So let's save this formatting so when we create new cross sections we don't have to reformat it. So I'll come over here to the templates and go File, Save as Template, and we'll just call this correlation. This is going to be our correlation template. Save it, and in the templates tab down here in the lower left, you'll see now we've got that default, which is just a stick format. In other words, no formatting at all. And this correlation, which I'm going to right click and set that as the default format. So anytime I now make a new cross section, it will make it with that format. Now I'm done with this one for now, so I'm going to go ahead and I've saved it. I'll save it again just for good measure. Close this one. And if I want to see what open cross sections I have, all I have to do is go to the window, and there it's going to show me the cross sections that I have open. Or likewise, you can see the cross sections you have open are highlighted over here in the cross sections tree. So I'm going to go ahead and close this one for now. I don't need it. And you see it goes from that magenta color to the black color, showing that it's available but not open. Now let's make a cross section on our own. So we're going to go to the cross section ribbon. I've got several types of cross sections. I'm just going to do the well-to-well cross section, but we can do projected. We can do buffered projected, that automatically buffers in wells into your line of section within a predefined buffer distance, and also block diagrams for looking at horizontal wells. But we're just going to go do a straight well-to-well cross section. We'll start with this well. Go here, here, just like you do if I was in GeoAtlas. And let's see, I think we're going to go this one next, and maybe this one, a couple more. Down here, I could either, when I finish, I could double click, or I can actually click out here, and you can actually extend your cross section beyond the extents of the wells because you're working in a 3D geomodel. Right click in the definition, and see it's automatically now formatted because we've got that template, that correlation template, set as our default template right here. Now, we probably want to do some picking on cross sections because, of course, that's why you do the cross sections. So I'm going to go to my Surfaces tab. That's going to show me all of the surfaces that are available, plus the surfaces that I've got turned on. And I'm going to be doing some correlation on the Bakken sand top. So the first thing I'm going to do is hit Torquay, which is this bottom one, bottom horizon right here, or bottom surface, and hit the space bar on my keyboard first to flatten it. And I'm going to be extending then the Bakken sand top, which is this top right here, into these other wells. And I'll zoom in for a little bit better clarity here, right down here in the middle of the cross section. And I want you to notice something right here. You see that solid dot? That means that the Bakken sand top is actually what we call a hard point. It's a saved depth, a measured depth in the well-based database. But notice over here I've got dashed lines here with the open square. That's what we call a predicted top. It's predicted by the geomodeling engine. This is the intersection of this surface with this line of section. So it's saying, according to the geomodel as it is so defined, that's where the geomodel thinks that top ought to be. Well, we're not so sure that's correct, so we're going to be doing some picking here. So with that surface as the active surface, we can come up here to this tool right here, Add Surface Points. And I will just eyeball it over and say, well, I think it belongs right there, and just make the pick. And immediately it becomes a hard point. It's put into the geomodeling engine and immediately modeled. Now, I'm going to show you some other ways of actually making some picks. So let me delete that pick first. Oh, it's gone. Come up here, and we're going to be doing a correlation log to help us make our pick. That's very much like the correlation log that you have in XSection, where my cursor now turns into my picker, and I simply line up the picks till I like it, then make the click, and there's my top. So that's all there is to. Now I'm going to do one more thing. I'm going to delete that point again. And I'm going to show you how to use what's called the quick pick mode. This is the mode that's very good if you have a very large cross section within a large AOI and you're modeling many thousands of wells with maybe a couple of dozen surfaces. And so as you make the picks go into the database, go into the geomodel, and go into any applied geomodeling tools you may have invoked, which is a great thing because it keeps everything synchronized at the same time. But there is some overhead, so it may take a 2 or 3 seconds or so for your cursor to return to the picking tool for you to make the next pick. But if you want to make the picks very quickly, what you can do is turn on your picker and turn on this mode here called Enable Quick Pick Mode. And what Quick Pick Mode does, it simply puts an annotation on your log, and it only shows as an annotation. I can now come in here and make some adjustments, say, well, I'm not sure it's there, maybe it's down there. Well, no, well, maybe it's up here. So you can play around with some what if scenarios. until you like what you want, like what you see. Now, the nice thing about this is it does have several layers of undo and redo. So if you do several different trial runs on here, you can back out, try them again, go back and forth until you're satisfied that that's the pick you want. Then you come up here and you click on the Save Quick Pick button. It puts it into the database, and it's now a model surface with that as a hard point in the well-based database. Now let's start applying some of the geomodeling tools. First, I want to turn on the detrital surface. Now the detrital surface is that unconformity surface at the top of the Madison group and the Bakken group here. And you can see that it's trying to downcut into these subcrop surfaces here. Let's look back at the GeoSurface modeling engine. Again, we can access it right there, that icon right there in the cross section. And let's look at another thing here in the Surfaces tab. We talked about where the source of these surfaces are. For example, here the detrital is coming from the data points in Wellbase. The detrital from the seismic volume is coming from the depth converted horizon coming out of GVERSE Geophysics. But another thing is important to understand is the surface type. We have two surface types. We have the formation and the unconformity surface types. So if you are going to be modeling unconformity truncations, you need to have the correct surface type defined, and these are defined in the Strat Column Manager. They're not defined here, so if I needed to change the type of surface, I need to go back to Strat Column Manager, make the change there, and then refresh our model. So the detrital is my unconformity surface. I do have other unconformity surfaces beneath the detrital unconformity, such as the Madison and the unconformity, not to be redundant, but there you go. Now, let's go over here to our networks. Now we're going to be networking because we want the Madison unconformity to truncate in the subcrop against the detrital unconformity. You also want this unconformity truncating against the detrital unconformity. So we have to network these older unconformities against this younger detrital unconformity. And we'll do this under networks. So we're going to network the Madison under the detrital and also this unconformity under the detrital. Click OK. Now all we've done is configured it. We haven't actually applied anything. So let's make this a little bit smaller and let's look at the map first. So I'm going to first turn on the detrital. This is the detrital surface as it is defined by the cross sections that we've just built. Now let's add some color. So right click on the detrital, go to Edit, Contour Options, come over to Fill, turn on the fill, and we have a number of different palettes we could apply. We'll just keep the default palette. So there it is. And remember, we did the load on demand when we first set up the configuration. To get back to setting up the load on demand, it's under the Edit ribbon, Interpretation Options, and see it says Load on Demand. That's why we don't have these other wells modeled with this detrital surface. So to do the load on demand manually, I'm just going to come up here to the upper left of the AOI outline and draw a selection box to the lower right to select those wells. Right click and load those wells into my interpretation. In other words, I'm loading them into the GeoModel, and they'll be immediately modeled with the triangulation and unconformity smoothing. And you see, this is how the configuration for this field is with just the well control. And let's put the well spots layer on top. So I'm going to click on the well spots layer in the layer selection box over here. Put it at the top so you can see where the wells are. Now we're trying to understand why this is producing. We can see there's a plunging nose over here, but it doesn't look like it's plunging over here, so maybe there's something else going on. So what we're going to do is start to apply some of the topology engine tools here. First of all, we're going to apply the conformance. That's going to maintain the conformance hierarchy. And again, I will remind you of this. The conformance hierarchy that we're going to set up here. Now, the detrital is the unconformity surface, and these surfaces are in the subcrop. So I want to model upward, and let's just pull up the cross section. Let's just pull up our little mini dip cross section here. Just double click to launch it. We're going to be modeling upward against the detrital unconformity. Let's make sure that's turned on. There's the detrital unconformity. We're going to be truncating upward against this unconformity. So I'm going to set up my hierarchy coming from the Bach and sand and working my way up in the conformance hierarchy that I'm going to set up. So we can do it directly from here. So we're going to be modeling from the Bach and sand. So I'm going to take the shallow stratigraphic and I'm just going to be stair-stepping like that. So the Bach and sand, which is that surface right there, is going to control the conformance of these surfaces as I come upward against the detrital unconformity. Likewise, here's how you can combine both surfaces that are built from well control. This detrital, again, I'll show you where that's coming from. The detrital gets its data points from well base, but the detrital from the seismic volume gets its surface information from GVERSE Geophysics. So to combine the two together, we'll just make the detrital from well base conformable to the detrital from the seismic volume. So now we've got that configured. Click OK, and if I look at the entire cross section, you'll start to see that my surfaces are still extending beyond my unconformity, but look at my unconformity here. It's being controlled away from the well control by that seismic volume. You can see a lot more detail because of the 3D seismic volume. But to finish configuring this, we need to apply the unconformity trimming and then the networking tool also. So when we do that and update the model, you'll see now that these surfaces are being truncated against, and let's turn on the 3D surfaces. You'll see they're being truncated against that detrital unconformity. So we've on the fly made our surfaces by simply picking them. That goes into the database and is modeled dynamically with triangulation unconformity smoothing. We've also combined a geophysical interpretation into my geological interpretation by inserting the depth converted seismic horizons coming out of GVERSE Geophysics and combining them with my well picks. And we've also modeled the subcrop. So let's see what the subcrop looks like. This is the detrital surface. We're going to turn off the detrital surface. And I'm going to come down here to my zone maps. Zone maps, I will again remind you, are these maps right here. This is a isochore map from the Madison to the detrital. Now, I had the detrital, which is really on the top, as the base because the smaller extent surface is going to control the extents of my map. So, because the Madison is in the subcrop, is the smaller extent surfaces. So let's turn on the Madison to detrital surface. And if we want to, we can add some color there. Maybe make it something a little more interesting. There's one down here called Stratum. It's kind of a fun color. So there you go. I can also model the truncation edges. So if I go back under here, under the detrital surface itself, I've got the unconformity list. And so for the Madison unconformity truncation edge, I can turn that on and I will just toggle off the zone map so you can see a little bit better. So there's the edge of the Madison unconformity as it's truncated against the detrital unconformity. And if I want to kind of combine both together, I can turn on the detrital surface and we're going to turn off the fill. So now we're just seeing the structure, and we can also turn off the contours on my Madison to detrital isochore map. So we'll come in here and we will turn off the contours, so just seeing the color. So now we're going to be draping the detrital surface on top of the truncation surface in the Madison, in the subcrop. So let's finish up by looking at everything in 3D. So I'm back on my Home tab. I'm going to open the 3D view. And by the way, anytime you have a cross-section open, it automatically becomes a fence diagram. And we can exaggerate the view a little bit by pulling it up here, make those fence diagrams stand out a little bit better. So there are our fence diagrams of our open cross sections. And we can also bring in our surfaces. So let's bring in the turquoise surface, maybe the detrital sand, maybe the Madison, and then there's the detrital surface itself. We can right click on the detrital surface, go to the properties, and we can add things like show the contours. So there's the contours of the detrital surface. We can do overlays on it, like the well spots. We can bring them on so we can see where the well spots are on that surface a little better. There they are. And maybe exaggerate this a little bit more. And then we can do things like clipping planes that will allow us to actually cut into our model so we can see what's going on in the subcrop a little more clearly by just truncating those surfaces. And you can see them line up with their corresponding correlation lines on the cross section. So there is your first configured GVERSE Geomodeling interpretation. I'm going to go ahead and save this. So now tomorrow morning when I come in and want to do some more work, I simply launch GVERSE Geomodeling, select my saved interpretation, and it brings me right back to this configuration of the display. Thank you for your attention.